Hello. In this video, we want to graph y equals sine of 4x. Now, to graph this, we want to graph the parent function, y equals sine of x. The x's are 0, pi over 2, pi, 3 pi over 2, and 2 pi. The y being 0, 1, 0, negative 1, 0. Good. Now, notice that this 4 is in there with the x. So we want to do y equals sine of 4x. Now, here's the thing. Because it is in with the x, that means that the y values will stay the same. Come on. So 0, 1, 0, negative 1, 0. But notice that the 4 is in front of the x, and then we have to do the opposite of what it says. That means we need to divide the x by 4. In other words, multiply by the reciprocal, which is 1/4. So that's going to give us 0 times 1/4 is 0. Pi over 2 times 1/4 is pi over 8. Pi times 1/4 is pi over 4. 3 pi over 2 times a fourth is 3 pi over 8. And 2 pi times 1/4 is 2 pi over 4, but that simplifies to pi over 2. Now, notice that one full cycle has just been completed in pi over 2 units. Excellent. Now, A here is the amplitude. A is 1, so the amplitude is 1, technically absolute value of 1, which is 1. B is 4, so the period here is 2 pi over 4, which simplifies to pi over 2. Notice that we start at 0 and we go to pi over 2. That means that the frequency would be the reciprocal of the period, but just flip it around. Pi over 2 becomes 2 over pi. So technically there are 2 cycles for every pi units. Alrighty. C here is, well, it's 0, so there is a phase shift of 0. And D is 0, so the average is again 0. Good. Now let's go up here. If we want to graph this, we want to notice that every time we go to the x's, we're going up about pi over 8. So what I want to do is I want to label each of these as pi over 8. So I'm going to label that as pi over 8. That as another pi over 8, which is pi over 4. Label that as another pi over 8, which is 3 pi over 8. And then this would be 4 pi over 8, which simplifies to pi over 2. And then notice that the y's stayed the same. So I'm just going to make this as 1 and negative 1 like that. And there we go. So 0, 0 still. Pi over 8, 1. Pi over 4, 0. 3 pi over 8, negative 1. And pi over 2, 0. Actually, I should be doing those in blue. There we go. Awesome. Now here's the thing. If we were to graph this, if you were to put this against the other graphs that we've done, you won't really see much difference. The reason is that we've created a scale here that makes it easier to see this frequency, this period. The reason that we did that is, well, for graphing purposes. Notice that if I had used the same scale that I originally did, where each tick mark was pi over 4, basically, instead of pi over, well, what would it be? Pi over 4, I think? Yeah. Instead of pi over 16. So it would look like this normally. Okay, so that's what it would look like normally, but with this one, what just happened is this, it looks like this. There we go. So notice that this has been stretched to look like this, and whereas the original looks like this. So notice that this happens in a much shorter distance along the x direction. This is why the period is smaller. But the frequency is the number per how many ever units, which means that the frequency is much larger here. So the larger the frequency, the smaller the period, and the larger the period, the smaller the frequency. There's an inverse relationship there. All right. I think I'm going to go ahead and end the video here, and I will see you in the next one. Have fun.